So today we are doing a little bit more factoring, but we're factoring by grouping. So how do I know when to use this method? Anytime you have a polynomial that has 4 terms, that's when you're going to use factoring by grouping. Okay, so as soon as you see a polynomial with 4 terms, you go straight to grouping. Okay? There are 6 steps to factoring by grouping, and then the rest is all examples. Okay, so step 1. We are going to group the first 2 terms. So we are going to set all of the terms in order by exponent, and you're going to group the first 2. And there's going to be a GCF, I guarantee it. So you're going to factor out that GCF. Then you're going to group the last 2 terms. And there'll be a GCF in there too, so you're going to factor out that GCF. And then we will end up with 2 sets of parentheses that should have the exact same thing inside. So that's what step 5 is. We just want to check to make sure there's the exact same thing in there. That's your new GCF. So you are going to factor out those parentheses. And that's the whole method. So, example 1. Okay. Example 1. We have x times y plus 2 plus 3 times y plus 2. This is not what your problems are going to look like. This is kind of at step 5. So notice how step 5 says make sure both parentheses are the same. That's what this step should look like. So after you factored out GCF, you should have 2 sets of parentheses that look exactly the same. Look at this, guys. What do you notice about this example? Is there a GCF in there? Yeah, what is it? Y plus 2. X is being multiplied by y plus 2, and 3 is being multiplied by y plus 2. So factor out y plus 2. One mistake that I commonly see is that when students factor out the y plus 2, they assume that we're multiplying them, and they put a y plus 2 squared. That is not correct. We are just factoring it out. So if you need to visualize it, I circle those and bring them out just as if we were doing the opposite of distributive property. So we get y plus 2 times what was left over after we factored it out. X plus 3. Bless you. Okay? So example 2, I have 2s times u plus y minus y times u plus y minus y plus u. Do I have a GCF in this problem? Yeah, u plus y. But this is a u plus y, this is a u plus y, and this is a y plus u. Does that make a difference? Why not? Because we're adding. This is the same as u plus y. Okay? In addition, order doesn't matter. Okay, so let's factor out the u plus y. So I'm going to factor out u plus y. And so then what am I left with? From this one I factor out and I'm left with 2s. What about this guy? If I factor out u plus y, what am I left with? Minus y. And what about here? Minus 1. Good. Okay, because anything divided by itself gives us 1. And that's your answer. Let's look at example 3. So let's actually look at this in action now. 2x to the third plus 6x squared plus x plus 3. This is what your problems will actually look like. I have 1, 2, 3, 4 terms here. All of them are in order. I have x to the third, x squared, x to the first, and no x, right? X to the 0. So they're all in descending order. So what we want to do here is we want to group the first 2 terms, and I put parentheses around them, and group the last 2 terms. Make sure that you group with the sign in front of that third term, because especially if it's a negative, that will make a difference. Okay, so that was step 1. We just wanted to group everything. So step 2 in our first group, I want to factor out a GCF. What's the GCF of the green group? 2x to the second. Good. So if I factor out a 2x squared, what is left inside green group? X plus 3. Okay, what about this one? Is there GCF in the orange group? No, so what we can do is we can just put the plus on the outside now, and we're going to keep x plus 3 in parentheses. Okay, because these two things are actually being added, not multiplied, right? So we need to make sure that plus stays in between the two. Okay? Alright, are my two sets of parentheses the same? Yes, which means we did it correctly. So what we're going to do is we want to factor out that x plus 3. So if I factored out the x plus 3, what's that going to give me? X plus 3 times what got left over? 2x squared plus 1. Excellent. You have to include the 1. It's not a 0 there. There's actually a 1 in front of that parentheses. Okay? And that's your answer. The reason why it's plus 1 is because whenever I divide a number by itself, what do I always get? 1. And factoring out something is just like dividing. So factoring out an x plus 3 divided by x plus 3 leaves me with a 1. Okay, so that's where the 1 comes from. Okay, example 4. 4d to the 5th plus d to the 3rd plus 8d squared plus 2. Okay, we have 1, 2, 3, 4 terms, so I know I'm going to use grouping. D to the 5th, d to the 3rd, d squared, d to the 0, so everything's in descending order, so I'm going to group the first 2 terms and the last 2 terms. Of the green group, what is my GCF?
D to the 3rd.
Good, d to the 3rd. So if I factored out a d to the 3rd, that's going to leave me with 4d squared plus d to the 3rd divided by d to the 3rd gives me a 1. Of the orange grouping, what's my GCF there?
4 or
2, a positive 2. So we're going to factor out a plus 2 there. Times 4d squared plus 1. Let's mentally double check. Are my parentheses the same? Yes, they are. So we're going to factor out the parentheses. So we're going to take that 4d squared plus 1, and that's what we're factoring out. So when I factor that out, what am I left with? D to the 3rd plus 2. And that's my answer. That's factored as much as I can. So example 5. We have 5x to the 4th minus 5x to the 3rd minus x plus 1. So here I have 1, 2, 3, 4, so I know I'm going to use grouping. X to the 4th, x to the 3rd, x to the 1st, x to the 0. So everything's in descending order from biggest to smallest. So I'm going to group the first 2 together, and I'm going to group the last 2 together. And this is why it's really important to group the sign, because especially when we have a negative, things might change a little. So in the green group, what is GCF? 5x to the 3rd times, okay, so I factored out 5x to the 3rd, so what am I left with? X minus 1. Okay, negative x plus 1, what's the GCF there? Good, negative 1. Okay, I have an x minus 1, and this should look like an x minus 1, but it doesn't. But if I factor out a negative 1, that's going to leave me with x minus 1. So if I divide by negative 1, negative x divided by negative 1 gives me positive x. Positive 1 divided by negative 1 gives me negative 1. So that's why it's very important to keep the symbol attached to the number behind it, because otherwise we would be just totally lost. Okay? So we pull out a negative 1 there, and now my two parentheses look the same, x minus 1 and x minus 1. So I'm going to factor that out, and I am left with 5x to the third minus 1. Last problem, example 6. 3a minus 6b plus 5a squared minus 10ab. Okay, so I have 1, 2, 3, 4, so I know that I'm going to use grouping. I have two variables involved here, so I'm just going to leave everything where it is. But let's group the first two together and the last two together. Okay, so looking at the first grouping, the green one, what's the GCF in there? Just a 3. So let's factor out a 3. That leaves me with a minus b. What's the GCF of the orange? 5a, good. So it's a positive 5a, so make sure you include the plus there. Thank you. My goodness, guys, my brain's like fried. Minus 2b. Okay, so if I factor out a 5a, that's going to leave me with a minus 2b. Perfect. So what can I do? Factor the a minus 2b. So factor a minus 2b, and what am I left with? A plus 5a. And you're done.
Everything must be 4 even.
Okay? That's factoring by grouping. You always use it when there's 4 terms. Group the first two and the last two. Pull out your GCF. And then you're going to pull out a third GCF, which should be 2 parentheses that are exactly the same. Okay?